Okay, let's this morning to where or why it wasn't recording. Sometimes it's strange. Every time it records just fine, I'm looking down to make sure the numbers are going. Time I turn my back, sure enough, it shuts off. Okay, so probably one of the things we had talked about earlier this morning was it's probably easier to sometimes write the compound out if this was given as one of your questions. Okay, and what that means is you can reverse engineer this. We use that from time to time. And then what this would allow you to do, all right, is just work backwards from the organic family to the parent chain to any derivatives and where they are and how many carbons are in that derivative. So as we're looking at this, we would say, all right, we know the organic family, it's an alkane, and there are 8 carbons in this compound. So we'll go ahead and we can safely put these carbons and hydrogens on here for right now. I was talking and writing at the same time. Sometimes I'm right, sometimes I'm wrong. So now we can start looking at here and work from left to right and say, all right, on our third carbon, we've got an ethyl group, which you can write it as this, C2H5, okay? That's a molecular formula as opposed to this structural formula that what we would see here, all right? And then on our second and sixth carbons, we see those are methyl groups that are located here. Or if you want to write it, for instance, as this. Okay, again, those mean the exact same thing. Here's a molecular formula. There's a structural formula for a methyl group. That's one of the things we talked about this morning that unfortunately we missed out upon, where I just didn't notice it was not recording. And another is our organic families. Of course, here we know we've got this alkane where it's saturated, it's showing carbons and hydrogens. And let's see here. I think I had something like this up there earlier this morning. Going through here. Would that be the organic family? Of course, when we have just a single bonded oxygen in the middle of this compound, we're referring to that of an ether then. It doesn't matter how many carbons you have on either side. You can have 3, 4, 5, or even 6 carbons on one side, and then sometimes even just one on this side, and that would be an ether then, because there's just, again, a single bonded oxygen. So then one of the things that ask the rest of the students, how could you convert this ether then an ester? So I want you to think about that for a moment and determine if you could see that in your mind, how you would change this ether to an ester. Okay, well, here's your clue. Okay, one of the things, there's a carbonyl carbon in there, which means you have to have a double bond oxygen someplace. And we can't just stick that double bond on any particular carbon. You have to go to specific spots. You would have to either go on this carbon or this one, because we have oxygen right there. So we'll just go ahead and go to the left, and we'll put our double bonded oxygen on top. So then, doing so, we need to make some changes to this compound. Okay? And that will be on your second carbon. You've got to make some changes just on account of this has 5 bonds. It can't do that. We'll go ahead and take this hydrogen off of here. And now we've changed ether to an ester now. Okay? Because we have this carbon that's attached single bondedly to this oxygen, and also has a double bonded oxygen on top. Okay? So there's two organic families, the ether and the ester. Now what I want you to think about, what would happen if I change this oxygen to a carbon now and put two hydrogens there. Now I want you to think about what organic family do you see there now. So it's got a carbonyl carbon on there because there's a double bonded oxygen on there. So if you said that was a ketone, you would be correct. Okay? So a ketone means you have a double bonded oxygen around your chain, and it's not on the first or end carbon, whichever way you want to refer to that. So this is a ketone, and here's the reason why, because you have that double bonded oxygen on there. I want you to think about change that ketone to an aldehyde now. So if you had to take that first carbon off, you would be correct. So one of the things you want to be careful for removing this first carbon, okay, we don't want to take this bond off, because this is a carbon-to-carbon bond now, okay? So upon doing this, we still want to leave that bond. Now we're showing that no longer is a carbon-to-carbon bond, but we to a hydrogen. So therefore, we've changed the organic family of that ketone to an aldehyde, because that double bond is on the first carbon. Okay? So I'm trying to think off the top of my head how many organic families there are. Just give me a moment. I believe there's 9. Okay? So let's just maybe count them out quickly. Okay, you had alkene, alkane, alkyne. Okay? Then alcohol, acid, ether, ester. What am I skipping here? I did acid already. Ketone, aldehyde. I think that's all of them. So yeah, those would be your 9 organic families. Yes, you could say there's amines out there too. We really don't get into those types of compounds until the spring. We start talking about amino acids. So I do believe, yes, there are 9. Okay. So the next thing I want you to think about, how would we change this structure? Well, we don't need to name this. We don't have to know that this is pentanal, at least not as of yet. We just want to know that this was an aldehyde. Okay? Again, we're not naming this. We got an aldehyde. None of these naming, because we haven't been taught that yet. Okay? So here we have this aldehyde. I want you to think about how to change it to an acid now. Fairly simple. Okay? And upon doing so, we still have to have this double bonded oxygen, and we'll change this to an OH. Now we've got an acid. Okay? So I do believe that was all of them. Okay? Well, with the exception of changing this back to this right here. Okay? Pentane. And if we change this to bond in here, which means I can take this guy back off. And is that correct yet? No, it's not. This second carbon, it's got too many hydrogens on there, so I'll go ahead and take him off of there. So now we change it from an alkane to an alkene. All right? And we change it to an alkyne. Okay? We really don't need to be shifting these double bonds anywhere, which means an alkyne's got triple, so I'm going to add him now and changes we have to make to this compound. Okay, so if you remove hydrogens, you would be correct. We've got to take this hydrogen off and this one. Now we've got our alkyne. So I just want to make sure I can double check. The first one we did was an ether, then we did an ester, and I think we talked about a ketone, aldehyde, acid, alkane, alkene, alkyne. So there's, and I do remember what it is, and it's very close to that acid because here is, we've got this double bonded oxygen and a hydroxy or OH group on there. So the last one we need to do to get to 9 is change this. We got to put a hydrogen here, take this off, and then now one of the things that would be important or vital in next chapter is being able to identify the different types of. Okay, this has a primary type because it's on the first carbon. You have to be able to identify secondary carbons and also tertiary carbons because tertiary types do not react in organic reactions. So that's something to keep in mind. Okay, so the last thing that we want to do is I've got this ring structure. Okay, I don't know if you can see it on there. Yeah, because I had a class, so maybe I'll go ahead and swing the camera over. Oop, wrong. I don't know if that really helps. Okay. So with this, I'll just make it a little bigger here so we can make sure that we see it. Okay, so we've got this, and we've got CH3 and CH3. Okay, so now if we just had this on here, we've got this ring structure, so we need to make sure we call it a cyclotype compound. Nothing on here but carbons and hydrogens would be cyclopentane. Now, if we covered these methyl groups up here, we could call this cyclochloropentane, just our halogen derivative there. Okay? Once we get more one type of derivative on there, we need to account for them all. And what takes priority, you might be thinking, you got to remember these have to go in alphabetical order. Nothing wrong with putting this up here for your chlorine or halogen group. And of course, we know this is a methyl group, and then another methyl group down here. So we've got two methyl groups and a halogen on there, and we can safely go ahead and write cyclopentane on here. Okay. So that's if nothing else was on here, we'd have cyclopentane. I want you to think about what is going to take priority on here. Well, when we do go through alphabetization, the chloral group would go first because the C comes before the M. Okay? But remember, there's dimethyl in there, but we disregard prefixes. So, 1 dash, this is taking priority. So, is that clockwise or clockwise? And in this case, it doesn't matter because if we go clockwise, we've got 1, 3, and 4. Or if we go counterclockwise, we've also got 1, 3, and 4. So dashes separate numbers and words. So 1 dash chloro dash 3 and 4 commas separate numbers. Remember, we have to that would still be in alphabetical order, but we disregard prefixes with the exception of isopropyl or isobutyl. So last thing, I did this earlier in the presentation this morning, so I'll go ahead and do that quickly. So as far as this alphabet type, okay, so if we had this, okay, and there's one more I wanted to put on there, and I think it was, maybe it was something like this. Okay, so what is it that's going to go first? If all these derivatives were on a compound, which one comes first? Remember, you disregard the prefixes with the exception of isobutyl and isopropyl. So in that case, we can go ahead and safely say we disregard that because it's a prefix. We disregard this because it's a prefix. Now we go to the derivative names. We've got E. We've got B for butyl. We don't disregard the isopropyl or isobutyl, so it's I. And then here we have our M. So the order that this would go, because of the alphabet then, okay, this one's 1, looks like this one's 2, then we've got this one's 3, that one's 4. Okay, I believe that's fairly accurately to what we had covered this morning, so hopefully this works. I've been checking my microphone, it has been blinking, and I see it's been recording the whole time. Alright, so that's all I have. Problem quiz tomorrow, and then the weekend is here. Of course, next Friday or Monday. Catch up to you next time.